Motion in a plane. Let us discuss the important topics, that is subtopics under this main topic, that is motion in a plane. You should be aware of the scalars and vectors. Take down scalars and vectors. Then under which we'll be discussing about the important definitions related to vectors like modulus of vector, unit vector, negative vector, positive vector, collinear vector, null vector, all these things we'll be discussing. Then I'll be explaining about the position and displacement vector, then that is a resultant vector and what are components of vector, then addition of vector and how to add this vector, what are the two theories associated with these vectors, and then the parallelogram law of vectors. So likewise it goes on. Okay. Then finally we'll be discussing about the addition and subtraction of two vectors, then multiplication of vectors. So likewise, it is almost like your vector algebra. So why they have given such a great importance to this vector algebra means without that it would be very difficult for us to explain about the or to know about the motion in a plane. So that is why we had to study exhaustively the I would say the vector algebra of this part. So then only we will be able to get into this topic. Okay. So the first one will be totally vector algebra mathematics, right? So you have to understand it very clearly and practice with various worksheet problems so that you can be very powerful in handling the vector related this two-dimensional motions. Okay. Then, secondly, after finishing this great topic, we will be explaining about the relative velocity. Take the relative velocity. What is relative velocity? Then third, I'll be explaining about the in which we will be discussing the projectile motion also. Okay, projectile motion. So that is the next topic. And where I'll be explaining about the that is when I say relative velocity, there are some problems associated with the for example raining and river crossing, etc. So there are so many interesting problems related to relative velocity. Then we will move over to the projectile mode, where we will be discussing about the mathematical analysis of projectile motion, and we will derive the equation of path of projectile, then time of flight, horizontal motion, range, etc. So these are all the very important concepts. Particularly, these are time taken and the horizontal range are very, very important with regard to projectile motion. And finally, we'll be discussing the uniform circular motion. Okay, where we'll be discussing about the centrifugal force, etc. Okay, uniform circular motion. Okay, right. Then we'll be explaining about the centripetal accelerations, etc. under this topic. Okay, right. Now let us proceed one by one. We will take up the first, the vector algebra part of it. So this is a very huge part topic. We will start with this. Take up vector algebra. By attending this session, probably that is you are completing your um, mathematics topic also, because I'll be handling most of the mathematical aspects also, so that it will be very useful for further studies in physics. Now, let us move to the scalars and vectors. You know, scalar quantities are scalar quantities. They are only physical magnitude, physical quantity, is it not? So magnitude, but no direction, no direction. So it is completely specified by a single number. Okay, specified by a single number. So these are all the various dimensions, or we can say various modes of methods of explaining the scalar quantity. And for example, when you consider temperature, will you mention the direction? No. When you have mass, will you mention the direction? No. So length, time, so these are all, and including work, W represents work. So these are all scalar quantities. Now let us consider vector. So the vector quantities have magnitude, both magnitude and direction. So that is why they obey triangle or parallelogram law of addition and subtraction. Addition and subtraction. And we can cite the examples like displacement. Okay. So displacement, velocity, momentum, force, velocity, momentum, then force, etc. Usually in your printed books, the vectors are indicated by bold letter. Okay. But when we write or take down notes or write in our examination, we cannot always use this bold. So that is why we represent this by, that is, putting an arrow at the top. For instance, when I say force vector means this one, but in your book they would be representing like this. Okay, so this is the force vector. So similarly, if you have got any A vector or B vector, you have to put the arrow mark from left to right. So that indicates the direction involved in the vector array. Okay, and suppose if you mention the velocity like this, the modulus of velocity means it gives the magnitude. So this is called modulus. We take the absolute value. So even if it is a negative value, it gives a positive value because it talks about only the magnitude. So when you want to remove the direction, what you can do, put the modulus so that you can remove and you can talk about only the magnitude here, right? Suppose your body, take down, has a velocity. Body has a velocity 40 meter per second due east. Okay, due east. If 1 centimeter is chosen, 1 centimeter is chosen to represent a velocity of 10 meter per second. A line OP, a line OP of 4 centimeter in length and drawn towards east and drawn towards east with arrowed at P, with arrowhead at P. That is OP means arrowhead at P. Will completely represent the velocity of the body. We used to say that is this is the vector direction. Let me call it, for instance, this is the tail portion of the vector, and the object is moving from O to P. This is the head. Now, when you say 1 centimeter means now it is at 1 centimeter is equal to that is a 10 meter per second. It is represented like this. So 1, 2, 3, and this is the fourth one. Are you able to understand? So it means that it is in the 40 meter per second speed. Okay. So it means you have got the tail, and this is also called, it has originated, it has started from this O, and it is now at P. So the direction is O to P. For example, whenever you indicate the direction, you know the convention. You have got at the top north, at the bottom south, and on the right side you have got east, and the left side west. So what is it indicating? The body is moving towards the east means this direction. Do you understand? Now, I want to, for example, the body is going here and it is going to take a reverse, right? So, OP means that is it is going towards north, east. What about that is OP when it is reversed? Can you tell me? That is from P to O. That is from P to O. But in the opposite direction. Opposite. So, in order to, you cannot put the left hand side arrow. So, instead, what you can do, either you can write PO, otherwise, you can write negative OP. Are you able to understand? So, OP that take the negative direction means reversed. So, this is the easy way of handling the directions. Do you understand? Now, what is the direction of this minus OP? It is westward, right? Yes. And what about this? This is east, right? Okay, so you should be able to understand just based on the symbolic representation of the vector. Now, I'll try to give you the very important definitions related to vector. So, as I already mentioned, modulus of a vector. What is that? Modulus of a vector. So the modulus of a vector, as you know, it is A vector. Modulus of a vector means that is A vector modulus. That gives you only the magnitude. Okay, right? Then, and this represents only the magnitude, no direction involved. Now, secondly, unit vector. How to get the unit vector? The unit vector is always represented by cap. So this is called A cap. Okay, take down A cap. It should be pronounced as A cap. Means unit vector. Is given by, you are able to get the unit vector when you divide the vector by its modulus of the vector. Are you able to understand this? So this is called unit vector. That is A cap. Okay. So what is this vector? This is vector, and this is modulus of vector. And this can also be represented as A vector divided by, you can simply put A also. Okay, so unit vector means, for instance, let me go here, say that is this is O, this is P, and this is at the 40 centimeter or 40 meter. per second speed. That is the velocity. So let us divide each centimeter as 10 meter. So 10 meter, 10, 20 meter, 30 meter, and 40 meter. Out of which we have got, so this 1 centimeter, the smallest one, the unit. Okay. So if it is 1/10 of this one, okay, that is called what? Unit vector. So if it is along the x-axis, for example, we can put the axis also like this. Let me say this is x, this is y, this is z. Or you can put this as y and this can be taken as z. So towards x-axis, you have got 1 centimeter, 2 centimeter, 3 centimeter. Likewise, it goes. It means they have got the unit vector I cap along the x-axis. Okay, and along the y-axis, it is called, that is 1 centimeter, 2, 3, etc. So this is called j cap. And along z-axis, that is above the plane of the paper. So what is that? It is 1, 2, 3. So in this way, it's moving. So it can be called k cap. Audible follow? So the unit vector along x-axis is called I cap. The unit vector along y-axis is called, and along z-axis it is called k cap. For example, an object is moving, say about a 5 meter per second. Okay, so 1, 2, 3, 4, 5. Okay, so this is in the fifth meter, right? And in which direction? That can be easily represented as phi I cap. Do you understand? When another object is moving in y direction, that is above, around the 3, means you can call it 3j cap. Are you able to understand? When another object is moving, it is around a 2, means 2k cap along the z-axis. So just by indicating I, j, k, we can easily point out in which direction that particular object is moving, right? Now let us move to the next concept. That is, better you type it, okay? Are you able to see the screen? Okay, right. Better type. So it is intended for direction only, right? Then let us proceed. Now, null vector. Let us talk about null vectors. Okay, null vector. So here, the vector with magnitude 0 is called a null vector, but it can take any arbitrary direction. Okay, so that is why it's called null vector. It is represented by 0 vector. That's called null vector, right? And the velocity, so you can indicate this, the velocity vector of a stationary object means it is not a moving, the stationary object. The acceleration vector of an object moving with the uniform velocity. So these are all the indications represented by the null vector. Then let us call the equal vector. Equal vector. Equal vector means, let me consider O to P. Another vector in the same direction with the same magnitude, that is, let us call SQ. So in that case, the magnitude wise, they are same. Okay. OP is equal to SQ. And also the direction wise, they are same. Therefore, they are called equal vector. It means both direction and magnitude are same. So they are parallel vectors and they maintain the equidistant also. Okay. And then Null vector in this case, that is, for example, when I say null vector, see, this is the origin. Now it is going to start towards the x-axis, but it's not yet started. It is at that direction, but it can move at any direction. But assuming that if it goes in this direction, then the same null vector can be what, that is, it does not see a vector can be identified only by the displacement. There should be some change in position. If there is no change in position, okay, but it has got the tendency to go toward x-axis. We are sure about x-axis means we can call this null vector as 0 I vector also. Okay, because we know that it is going to move in this direction only, but right now it is stationary. Similarly, you can mention the y and z also. That is as j cap and k cap. Okay, so when I say null vector means you cannot say the direction is a zero, but the magnitude is zero. Do you understand this? Okay, right. Now the equal vectors. Equal vectors means that is, as I already mentioned, the OP, the magnitude, as well as the direction of both these vectors are same, and that is why they are called equal vectors in all aspects, right? And yeah, and let us talk about these negative vector. Okay, negative vector. What do you mean by negative vector? If it goes in the opposite side, then you can call it negative vector. Okay, for example, O to P. This is OP vector. Now the object is moving in this direction. That is from P to O. So this can be represented by putting minus and the same direction OP. It indicates that is it is traveling from P to O. So this is called negative vector. Collinear vector. Take down. Collinear vector. Collinear vectors. Let me consider a vector A, another vector B. Okay. So A vector, B vector. These vectors are said to be collinear, and they can act along the same line as same lines or parallel lines. For example, let us consider the tug of war. Okay, so when you have got these two vectors, okay, and they can be represented along a same direction, and here you can have the like parallel vectors. When the two collinear vectors are in the same direction, they are called like parallel. Okay, take down like parallel vectors. Okay, like parallel vectors. And when the two vectors are in opposite direction, but they are acting in the same line. Okay, like this tug of war or this type. They are acting in the same line, but they are in the opposite direction. So they can be called that is anti-parallel vectors. Okay, anti-parallel vectors. And the angle between them will be 180-degree in this case. Okay. Then coplanar vectors. Coplanar vectors. Coplanar vectors means that they are lying in the same plane. Let me consider vector A, vector B, vector C. All are lying in the same plane. For example, a vector goes like this, vector A. Another vector goes in this direction, vector B. Another vector, it goes in this direction, vector C. Okay. So they can be called all these together because they are acting on the same plane. Okay, that's why they are called coplanar vectors. Okay, they co-initial vector. Co-initial vector means the two vectors have the same common origin. So co-initial vectors means, for example, from O, here A would have started like this vector. Another vector B would have started like this, but from the same plane, that is same point. Okay, so they have the same initial point, and that is why they are called co-initial vectors, right? And we have orthogonal vectors. Take down orthogonal vectors. Orthogonal vectors. So orthogonal vectors means these vectors they are mutually perpendicular to each other, as in the case of x-axis, y-axis, and the z-axis. Let me consider this is x-axis. Okay, so we have got one vector p vector. Another vector it is moving towards along the y-axis. So let me call it this is the q vector. Another vector it is traveling above the plane of the paper, but that cannot be represented in this way. So that is why I am giving a perspective view. So it means Z, and this vector is called R vector. Okay. So all these P vectors, so P vector is perpendicular to Q vector, that is perpendicular to R vector. So such type of vectors are called orthogonal vectors. Suppose if they have unit vectors, for instance, this is a unit vector. Unit means one, basic unity. So along the x-axis you call it, what is that? I cap, is it not? And along the y-axis, j cap. And here, k cap. Okay. So I j cap. It means, for instance, I cap, as I already mentioned, this is nothing but just a minute.